Bright Tuty. Every student matters.
Now, on the basis of the understanding that we had done, let us do these questions. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. Now, let us recollect what did Thomson say about his atomic model. According to Thomson, he said that atom is a positive mass where there are negative charges which are embedded on it. And these positive charges and the negative charges, they are equal. So because they are equal, they are electrically neutral. So on the basis, how will you explain that atom is neutral as a whole? We can explain an atom is neutral as a whole by taking the entire mass of an atom to be positive mass and the negative charges embedded in it, such that the negative charges are uniformly distributed throughout the positive mass and thus they are electrically neutral. The second question, on the basis of Rutherford's model of atom, which subatomic particle is present in the nucleus of an atom? What do you think? Now let us recollect what did Rutherford conclude. He concluded that atom consists of a centrally located heavy mass, and what did he say about the charge? It contains positive, it is positively charged. So when can that happen? If it is positively charged, then which subatomic particle would be present? Yes, definitely. The subatomic particle which is present in the nucleus of an atom is proton. Fine. So we can answer these questions on the basis of this. Alright, now let us continue with the question answers. Now in this question, it says that draw a sketch of Bohr's model of an atom with 3 shells. Now as I had already explained you, Niels Bohr's model of an atom. Now in Niels Bohr atom, he said that there is a centrally located positive nucleus, just as Rutherford had said. And according to Niels Bohr, the electrons are revolving around discrete energy levels. And each of these electrons in the levels are revolving in this particular energy shells. So let us draw this. So first we need to draw the nucleus. So this is the nucleus which is positively charged, and then we have the extranuclear part. Now here you would see that in the question it is mentioned that there has to be 3 shells. That means we can have shell 1, shell 2 and shell 3. Okay, let me make some correction here. So shell 1, shell 2 and shell 3. So this is the nucleus. This is the nucleus of the atom. This would signify the K shell, that is N equal to 1. L shell, N equal to 2, whereas M shell, N equal to 3. So this is Bohr's model of an atom with 3 shells. Shell K, that is the first shell, shell L, the second shell, and shell M, the third shell. Now the next question. What do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of a metal other than gold? Now one thing we need to understand about the property of gold and any other metal. We know that metals are malleable. They are highly malleable. Malleable means they can be beaten into thin sheets. Now when it comes to all the metals, gold is the metal which has the highest malleability capability. That means you can beat down gold into very thin sheet. Whereas other metals would also show the property of malleability, but the extent to which the gold shows, it would not match up to it. So gold shows the maximum malleability in comparison to other metals. So if the alpha ray particle scattering experiment would have been carried out with any other metal other than gold, then maybe the alpha particles would not have shown any deflection or deviation by any small angle, and there would have been no observation at all. But taking gold into account, it showed that it had brought the layer of atoms to the minimal. And we know that in alpha ray scattering of Rutherford's model, he had used a thin gold foil whose thickness was around 1000 atoms. So that helped in the observation of Rutherford's model. Now, so this clearly states that if we would have had any other metal, then it would not have been applicable because the malleability would have been very less in comparison to gold, where gold is highly malleable, and thus the observation would not be in accordance. Okay, so you understand that had we taken any other metal other than gold, then the observation would have been very, very different. In fact, there would have been no observation at all. Okay, so I hope with this concept, the structure of an atom is completely clear to you. We saw that there has been a gradual progress in the discovery of the subatomic particles with the discovery of electron followed by proton. After the subatomic particles were discovered, then the structure of atom was formulated. And in structure of atom, it clearly showed that the positive and the negative charges are uniformly distributed. And the first model was given by J.J. Thomson. Taking that to be true, Rutherford carried out his famous alpha ray scattering experiment, and he found that the positive protons are not scattered throughout the atom, but rather they are in the center of the atom, and that center which holds the maximum mass of an atom is positively charged, whereas the electrons are in the extranuclear part. But we had already seen that the Rutherford's model had certain drawbacks, and the drawback was that if electrons are revolving around the nucleus, then gradually they are going to radiate energy, that is lose energy, and as they lose energy they would have become weak and finally would come and collapse with the nucleus, which does not happen at all. So making some rectification, Niels Bohr came out with his final model of atom, and he said that yes, the protons are present in the nucleus, but the electrons are present in discrete energy levels. And for any electron to be in a particular energy level, it should have that quantity of energy with it. So an electron can jump from one energy level to the other by either losing energy or gaining the energy. And taking all these concepts in mind, we had also solved some questions. Now let us go to the next one.